Very hearty good evening to all our viewers of the program and participants of the program in this online workshop on circle and its properties. आप सभी का स्वागत है इस राष्ट्रीय गणित दिवस के वीक लॉन्ग सेलिब्रेशन के दौरान आयोजित होने वाली सर्कल एंड इट्स प्रॉपर्टीज की ऑनलाइन कार्यशाला में, जो कि आयोजित की जा रही है रीजनल साइंस सेंटर भोपाल के द्वारा इन कोलैबोरेशन विद National Council for Science and Technology Communication under the Department of Science and Technology, New Delhi, and MP Council of Science and Technology. आप सभी पार्टिसिपेंट का स्वागत है इस ऑनलाइन कार्यशाला में, जो कि आयोजित की जा रही है रीजनल साइंस सेंटर भोपाल के द्वारा नेशनल काउंसिल फॉर साइंस एंड टेक्नोलॉजी कम्युनिकेशन अंडर द डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी एवं एमपी काउंसिल फॉर साइंस एंड टेक्नोलॉजी के संयुक्त तत्वाधान में आप सभी का मैं स्वागत करता हूं इस कार्यशाला में। जैसा कि बताया गया था कि ये कार्यशाला गूगल मीट पर एक हमारे पार्टिसिपेंट के साथ एक म्यूचुअल इंटरेक्शन के बाद हमारे यूट्यूब चैनल पर लाइव कर दी जाएगी। सो वी आर लाइव ऑन आवर यूट्यूब चैनल एज वेल। सो वी आर लाइव ऑन आवर यूट्यूब चैनल एज वेल। आप सभी पार्टिसिपेंट से रिक्वेस्ट करूंगा कि जल्दी जल्दी जितने भी लोग हमारे साथ जुड़ गए हैं अपना नाम, अपनी क्लास और आप कहां से, किस सिटी से आप पार्टिसिपेट कर रहे हैं, उस पे किस सिटी से आप पार्टिसिपेट कर रहे हैं उसको हमारे साथ जल्द से जल्द साझा करिए प्लीज। हरी अप। जल्दी जल्दी आप हमारे गूगल मीट के इस चैट बॉक्स में अपना नाम, अपनी क्लास और किस सिटी से आप पार्टिसिपेट कर रहे हैं वो हमें जल्दी जल्दी भेजिए। उसके बाद हम मूव करेंगे अपने यूट्यूब चैनल पर जहां पे पूरी क्लास कंटिन्यू कराई जाएगी। सो आप सभी का स्वागत है एक बार पुनः इस कार्यशाला में। जल्दी से जल्दी बिना समय गवाए अपना नाम, अपनी क्लास और फ्रॉम विच सिटी यू आर पार्टिसिपेटिंग प्लीज टेक्स्ट अस। हरी अप। और जो दर्शक हमें हमारे YouTube चैनल के माध्यम से भी देख रहे हैं मैं उनसे भी सब रिक्वेस्ट करूंगा कि अपना नाम और इफ यू आर स्टूडेंट आप अपनी क्लास और आप हमें किस जगह से देख पा रहे हैं, किस जगह से आप इस ऑनलाइन कार्यशाला में भाग ले रहे हैं उस जगह को जल्दी से जल्दी आप टेक्स्ट करिए सो दैट वी कैन स्टार्ट द प्रोग्राम वेरी सून। आंचलिक विज्ञान केंद्र भोपाल, नेशनल काउंसिल फॉर साइंस एंड टेक्नोलॉजी कम्युनिकेशन, डिपार्टमेंट ऑफ साइंस एंड टेक्नोलॉजी न्यू दिल्ली और एमपी काउंसिल ऑफ साइंस एंड टेक्नोलॉजी के संयुक्त तत्वाधान में वीक लॉन्ग सेलिब्रेशन ऑफ नेशनल मैथमेटिक्स डे मना रहा है। वी आर सेलिब्रेटिंग द लीजेसी ऑफ नन अदर देन श्रीनिवासा रामानुजन। सो इस वीक लॉन्ग सेलिब्रेशन के प्रोग्राम में हमने ढेर सारे कार्यक्रमों का आयोजन किया, जिसमें सबसे पहले दिन यानी कि 22 दिसंबर को हमने एक प्रदर्शनी का वो अपने YouTube चैनल के माध्यम से अनावरण किया जिसका नाम था द मैन हु न्यू इन्फिनिटी। सो इस प्रदर्शनी को हमने अपने YouTube चैनल पर अवेलेबल किया है। तो आप सभी लोग से मैं रिक्वेस्ट भी करूंगा कि जो भी इच्छुक हैं वो सभी लोग इस प्रदर्शनी को ऑनलाइन देख सकते हैं जिसका नाम है द मैन हु न्यू इन्फिनिटी। इसी वीक लॉन्ग सेलिब्रेशन के दौरान हम लोगों ने और अन्य कार्यशालाओं का भी आयोजन किया जिसमें कुछ ट्रायंगल एंड इट्स प्रॉपर्टीज जो कि ऑलरेडी हो चुकी है। साथ ही साथ हमने सर्कल एंड इट्स प्रॉपर्टी जो कि हम आज आयोजित करने जा रहे हैं, कल हम लोगों ने जियोमेट्रिक शेप्स एंड इट्स मॉडलिंग पर कार्यशाला कराई। अभी होने वाले प्रोग्राम्स में शामिल है ऑनलाइन क्विज जिसकी डिटेल्स आपको हमारी वेबसाइट से मिल जाएगी और साथ ही साथ और भी हमारे साथ जो कार्यक्रम होने वाले हैं उसमें शामिल है हाइपरबोला एक्रोबेटिक स्टिक पर होने वाली एक ऑनलाइन कार्यशाला जो कि स्पेशली ऑर्गेनाइज की जा रही है केवल 11th और 12th क्लास के स्टूडेंट्स के लिए। तो जो भी इच्छुक बच्चे हैं अगर जो हमें YouTube माध्यम से या या आप जो भी एग्जिस्टिंग पार्टिसिपेंट्स हमारे साथ वर्कशॉप में जुड़ चुके हैं, अगर आप ये भी आपके आसपास में या कोई अगर 11th और 12th का बच्चा इस क्लास को इस वर्कशॉप में, इस ऑनलाइन वर्कशॉप में पार्टिसिपेट करना चाहता है, जो कि हाइपरबोला यानी कि हाइपरबोला और हाइपरबोला एक्रोबैटिक स्टिक पर होने वाली है, तो उसको उसमें आप पार्टिसिपेट कर सकते हैं। रजिस्ट्रेशन की सारी डिटेल्स आपको हमारी वेबसाइट www.rscbhopal.gov.in पर मिल जाएगी। तो जो भी इच्छुक पार्टिसिपेंट्स हैं, जो भी इस कार्यशाला में भाग लेना चाहते हैं, वो वहां से लेकर के हमारे साथ जुड़ सकते हैं। तो बाय द टाइम आई वंस अगेन रिक्वेस्ट ऑल माय फेलो पार्टिसिपेंट टू प्लीज टेक्स्ट अंडर द chat box of Google Meet and YouTube channel as well your name, your class, and from which city you are participating in this online workshop on circle and its properties. जैसा कि आप सभी लोगों को मालूम है, जो हमें इस समय कार्यक्रम में जुड़े हुए हैं, कि इस कार्यक्रम में जो फर्स्ट 100 पार्टिसिपेंट होंगे मध्य प्रदेश राज्य से, उनको हमारे द्वारा किट प्रोवाइड की जाएगी जिस वर्कशॉप में वो पार्टिसिपेट कर रहे हैं। लेकिन फर्स्ट 100 पार्टिसिपेंट को तो मैं जस्ट एक आपको झलक दिखाने जा रहा हूँ, जिसमें कुछ जो एक शीट है जिसमें पार्टिसिपेंट्स रजिस्टर्ड पार्टिसिपेंट का ग्लिम्स है, जिसमें मैंने हाईलाइट किया है जो लोग बाहर से पार्टिसिपेट कर रहे हैं। और उन सभी बच्चों को भी मैं धन्यवाद देना चाहूँगा कि जो हमें आउटसाइड एमपी भोपाल से पार्टिसिपेट कर रहे हैं। थैंक यू फॉर शोइंग योर इंटरेस्ट इन दिस प्रोग्राम, इन द प्रोग्राम्स ऑर्गेनाइज्ड बाय रीजनल साइंस सेंटर भोपाल। और जो लोग अभी तक हमारे साथ जुड़ गए हैं, मैं उनसे रिक्वेस्ट करूंगा कि आप इस तरह के प्रोग्राम की प्रायर नोटिफिकेशन, प्रायर इंफॉर्मेशन पाने के लिए हमारे यूट्यूब चैनल को सब्सक्राइब करिए और बेल आइकन दबाइए। हमारे यूट्यूब चैनल को सब्सक्राइब करिए और बेल आइकन दबाइए, ताकि आपको इस तरह के होने वाले सभी प्रोग्राम की प्रायर नोटिफिकेशन मिल जाए। सो मैं जस्ट आपको एक ग्लिम्स दिखाता हूं हमारी जिन बच्चों ने जस्ट दिस इज द रजिस्ट्रेशन शीट जिन्होंने हमारी इस कार्यशाला में भाग लिया। इसमें जो हाईलाइटेड है, मेरा सबसे ज़्यादा धन्यवाद इनको दूंगा कि इन्होंने बाहर दूर भी रह करके हमारे इस कार्यशाला में पार्टिसिपेट किया। सो थैंक यू वेरी मच टू ऑल द पार्टिसिपेंट हु आर पार्टिसिपेटिंग इन दिस ऑनलाइन वर्कशॉप ऑन सर्कल एंड इट्स प्रॉपर्टीज। कुल 116 लोगों ने रजिस्टर किया था इस कार्यशाला के लिए। 116 लोगों ने रजिस्टर किया था इस कार्यशाला के लिए, एवं बाहर के इसमें जो बच्चे हैं वो उनकी संख्या 15 है एज पर माई शीट। सो जल्दी जल्दी आप सभी लोग आप सभी बच्चे जो हमारे साथ वर्कशॉप में जुड़ चुके हैं अभी तक 51 पार्टिसिपेंट, आप सबको मेरी आवाज़ सुनाई दे रही है तो जल्दी जल्दी टेक्स्ट बॉक्स में यस करके टाइप करिए सो दैट वी कैन हम ये मान सके कि हम हमारा बात आप समझ पा रहे हैं। वेरी गुड, वेरी गुड, थैंक यू वेरी मच, थैंक यू टू ऑल ऑफ यू फॉर सच अ प्रॉम्प्ट रिस्पॉन्स, थैंक यू एवरीवन एंड थैंक यू, आई गॉट इट। सो जल्दी से अभी तक जिन लोगों ने नहीं लिखा है वो लोग हम जल्दी जल्दी अपनी डिटेल्स भेज दें, अपने नाम, क्लास और अपना सिटी फ्रॉम वेयर यू आर पार्टिसिपेटिंग इन द वर्कशॉप। और आज की जो हमारी किट है उसका नाम है सर्कल एंड इट्स प्रॉपर्टीज। तो ज़्यादा समय ना लेते हुए बस 2 मिनट के अंदर मैं आप सबसे डिस्कस करूंगा कि किस तरीके से हम लोग बनाएंगे इस किट को। तो जस्ट एक डिजिटल प्रेजेंटेशन के माध्यम से मैं आपको बताना चाहूँगा यूजिंग पेंट प्लेटफॉर्म, उसको देख करके आप समझ सकते हैं। फिर आप जाएंगे इसके जो थ्योरेटिकल पार्ट है इस किट का, इस कंसेप्ट का जो थ्योरेटिकल पार्ट है उसको आप समझने का कोशिश करेंगे और साथ ही साथ फिर आप एग्जैक्टली किट कैसे बनाई जाती है वो भी देख पाएंगे। तो सबसे पहले मैं शुरुआत करूंगा डिजिटल प्लेटफॉर्म से। तो बस मैं 2-3 मिनट और वेट करूंगा, जल्दी से जल्दी आप हमारे साथ जुड़िए और जल्दी से जल्दी अपनी सारी डिटेल्स गूगल मीट प्लेटफॉर्म में, गूगल मीट के चैट बॉक्स में और हमारे यूट्यूब चैनल के चैट बॉक्स में भी हमें जल्दी से जल्दी साझा करिए। गूगल मीट के प्लेटफॉर्म में और यूट्यूब के चैट बॉक्स पे जल्दी से जल्दी अपना नाम, अपनी क्लास एवं आप कहां से पार्टिसिपेट कर रहे हैं सभी लोग जल्दी जल्दी। बाय नाउ अभी तक हमारे साथ 53 पार्टिसिपेंट जुड़ गए, जिसमें से 2 अगर मैं हटा दूं तो 51। अच्छा, जिन लोगों ने यहाँ पर चैट बॉक्स में टेक्स्ट कर दी है डिटेल, वो यहाँ से जल्दी एग्जिट ले लें। जिन लोगों ने यहाँ से चैट बॉक्स में अपनी डिटेल्स भेज दी है, दे कैन टेक लीव एंड दे कैन स्विच टू आवर यूट्यूब चैनल जहाँ पे हम लोग ऑलरेडी लाइव हैं। सो जो भी पार्टिसिपेंट अभी जुड़ रहे हैं, अभी जो पार्टिसिपेंट जुड़े हैं उनसे मैं रिक्वेस्ट करूंगा कि जल्दी से जल्दी चैट बॉक्स में अपना नाम, अपनी क्लास और आप किस सिटी से पार्टिसिपेट कर रहे हैं वो जल्दी जल्दी हमारे साथ साझा करिए, हमारे चैट बॉक्स में लिखिए और फिर स्विच करिए हमारे यूट्यूब चैनल पर जहां पे हम लोग ऑलरेडी लाइव हैं। यूट्यूब चैनल के लिए मैं आपको बताना चाहूंगा, जस्ट यूट्यूब पे जाइए और लिखिए रीजनल साइंस सेंटर भोपाल। आप हमारा पेज आपको सबसे पहले ही मिल जाएगा, वहां पर आप हमको हमारा लाइव प्रोग्राम को देख सकते हैं। और इसको ज्यादा से ज्यादा शेयर भी करिए ताकि आपके जो फेलो पार्टिसिपेंट्स हैं जो इवन 9th-10th में नहीं है उनको भी आप YouTube चैनल को भेज सकते हैं ताकि दे कैन हैव अ लुक टू आवर वर्कशॉप एंड दे कैन एंजॉय इट एज यू विल बी एंजॉयिंग। ओके, सो जल्दी से जल्दी आप उसको शेयर कर दीजिए। और एक मेरी रिक्वेस्ट सभी से रहेगी कि डू सब्सक्राइब अस सो दैट आपको हमारे आने वाले प्रोग्राम की प्रायर नोटिफिकेशन मिल जाए। थैंक यू वेरी मच।
Sir, we have to attend this workshop through YouTube or through Meet only?
No. The workshop will be conducted only on YouTube channel. After the mutual interaction, I request you to please shift to our YouTube channel only. No one will be there in the Google Meet platform. Am I clear?
Okay, sir.
Yeah.
Yes, sir.
Okay. ओके, मैं आप सभी से रिक्वेस्ट करूंगा कि यहाँ पे अगर आप लोगों ने अपनी डिटेल्स भेज दी है तो आप जल्दी से अब यहाँ से मीटिंग लेफ्ट कर दीजिए और हमारे साथ यूट्यूब पे जुड़िए सभी लोग। चेतना जी, हेमंत जी, श्रुति जी, प्रिंस जी, चारू कृष्ण वर्मा जी एंड अगर मैं किसी का नाम, विराट जोशी जी एंड सरिता परिहार जी, सभी लोग प्लीज यहाँ से अगर आपने टेक्स्ट कर दिया है अपनी डिटेल्स तो प्लीज लीव द मीटिंग। हेमंत जी प्लीज, चारू कृष्ण वर्मा प्लीज, चारू, if you are getting my voice please and text your details and leave the meeting please. Charu, okay, I am removing from my end to you, from my end. Who is this? अभी मीटिंग में जो भी है मैं उनसे रिक्वेस्ट करूंगा कि आप अपनी डिटेल भेज करके प्लीज लेफ्ट करिए। थैंक यू श्रुति। आप सभी लोग हमसे यूट्यूब के माध्यम से जुड़ सकते हैं, यूट्यूब के माध्यम से जुड़ सकते हैं। ये मैं आप सभी लोगों के डिटेल्स एक बार फ्लैश कर देता हूं। आप सभी लोगों ने अपना डिटेल भेज दिया है। थैंक यू वेरी मच फॉर दिस एंड आई एम जस्ट स्टार्टिंग द वर्कशॉप ऑन सर्कल एंड इट्स प्रॉपर्टीज। And during the workshop I request you to keep on posting your questions। और बीच में बच्चे जैसा कि मैंने कल देखा कुछ आपस में ही चैट करने लगते हैं, तो do not use the YouTube platform for chatting purpose as well because we are continuously monitoring the platform. Okay, so I request you to concentrate on class. Okay, and आप सभी लोगों को एक गूगल फॉर्म भी भेजा गया होगा जिसमें आपसे रिक्वेस्ट की गई होगी कि आप अपना ईमेल आईडी अपना एड्रेस प्रूफ अटैच करिए, जिससे कि आपको पता चले, हमें पता चल पाए कि कौन कहाँ से पार्टिसिपेट कर रहा है। तो जैसे ही मैं आपको भेजूंगा आप सभी से मैं रिक्वेस्ट करूंगा कि आप लोगों को वो जल्दी ही गूगल फॉर्म मिल जाएगा। आई रिक्वेस्ट राहुल टू प्लीज चेक वेदर माई वॉइस इज कमिंग और नॉट ऑन यूट्यूब प्लेटफॉर्म, on YouTube platform whether my voice is audible or not। और मैं अपने पार्टिसिपेंट से भी रिक्वेस्ट करूंगा कि प्लीज चैट बॉक्स के माध्यम से भी हमें बताएं अगर आप मेरी आवाज सुन पा रहे हैं तो प्लीज लेट मी नो यूजिंग द चैट बॉक्स। ओके ओके, थैंक यू, आई गॉट द कंफर्मेशन। अभी जो हमारे साथ जुड़े हुए हैं बच्चे, मैं उनसे रिक्वेस्ट करूंगा, शेफाली एंड मोनिका, प्लीज लीव दिस गूगल मीटिंग एंड टेक्स्ट योर नेम, class and from which city or which place you are participating. Monica, please text and leave the meeting and switch yourself to our YouTube channel. The link has already been shared with you और by today evening आज आपको एक लिंक और भेजी जाएगी जिसमें आपको अपनी डिटेल्स, अपना आधार कार्ड या अपने स्कूल के आइडेंटिटी कार्ड को अपलोड करना है। ठीक है मोनिका, if you are getting my voice please text your details and leave the meeting.
Okay.
Yeah. ओके, अब जस्ट मैं कुछ ही सेकेंड्स में शिफ्ट करने जा रहा हूं। सिद्धेश जी प्लीज, सिद्धेश भागवत has texted me, sir, when we will get the mathematics key. First please I request you to please focus and concentrate on our workshop. We will talk about this. Okay, now Monica, have you texted your details or not? विराट जोशी और जो भी अभी हमारे साथ YouTube पे जुड़ रहे हैं,
Yes, sir.
हाँ, आपने टेक्स्ट कर दिया डिटेल, तो देन प्लीज लीव द मीटिंग। ओके, if you haven't texted please text it and leave the meeting please। विराट जोशी, अगर आपने डिटेल्स अपनी टेक्स्ट कर दी है तो जल्द से जल्द मीटिंग को लीव करिए और YouTube चैनल पर शिफ्ट होइए। बाय द टाइम मैं सभी पार्टिसिपेंट से रिक्वेस्ट करूंगा कि हमारी इस लिंक को ज़्यादा से ज़्यादा अपने चैनल्स में शेयर करिए सो दैट एनीवन हु इज इंटरेस्टेड इन दिस काइंड ऑफ ऑनलाइन वर्कशॉप, हैंड्स ऑन वर्कशॉप, वो पार्टिसिपेट कर सके और इस कार्यक्रम का आनंद उठा सके। Okay, Viraj Joshi, please text and leave the meeting. Viraj, are you getting my voice? Okay, thank you. Only if I'm not wrong, the person with initials M, I forgot your name, sorry. पता नहीं शायद, हाँ, yeah, it is written over there. Monica Madasu. Yes, Monica, please text, hurry up and leave. और अगर जो लोग बाद में हमसे जुड़ रहे हैं, अगर वो नहीं टेक्स्ट कर पाए तो कोई बात नहीं, यूज आवर चैट बॉक्स, यूट्यूब चैट बॉक्स, और उसमें आप जल्दी से जल्दी हमारे साथ शेयर करिए नाउ. ओके, ठीक है, मैं जस्ट शुरू करने जा रहा हूं हमारी वर्कशॉप, जो कि है ट्रायंगल एंड इट्स प्रॉपर्टीज पे. तो आई होप आपको मेरी पेंट की स्क्रीन दिखाई दे रही होगी. जस्ट मुझे चैट बॉक्स के माध्यम से बताइए इफ यू आर एबल टू सी माय स्क्रीन on our YouTube channel. If you are getting my screen on our YouTube channel, नहीं मेरे तरफ से क्लियर है, इट्स क्लियर फ्रॉम माय एंड. ओके, ठीक है, ओके, यस, ओके. आई थैंक यू फॉर द कंफर्मेशन. थैंक यू कार्तिक, थैंक यू विजय मौर्य जी, तुजा अवस्थी जी, और ओके ओके, चेतना जी, चेतना घोष जी, my the visible screen is sufficient because I am also monitoring. This is sufficient view. Okay, and one thing I also request to all our participants that whenever you are participating in any of these kind of workshops, I request you to please your own email ID. Now it's absolutely free, so you may create your email ID and you have to use your own email ID, your own personal detail whenever you are participating in such kind of workshop. So without taking much of your time, मैं शुरू करता हूँ हमारी वर्कशॉप, जिसका नाम है सर्कल एंड इट्स प्रॉपर्टीज. तो सर्कल में आज हम लोग दो थ्योरम्स के बारे में पढ़ने की कोशिश करेंगे. इसमें पहली थ्योरम क्या कहेगी कि मैं आपको बताता हूँ. जो आज आप किट बनाएंगे, हमारे सर्कल्स में दो बड़ी इंपॉर्टेंट थ्योरम होती है कि सर्कल्स को, अगर कोई सर्कल है, ठीक है, मैं जस्ट अभी डिजिटली आपको टूल को प्रेजेंट करूंगा. इसके जो थ्योरेटिकल पार्ट है अभी माय कलीग्स एनबी शाहू सर विल डेमोन्स्ट्रेट यूजिंग आवर किट. तो बाय द टाइम, इन द मीन टाइम, मैं आप सभी से रिक्वेस्ट, मैं यहाँ पे आपको डिजिटल टूल्स के माध्यम से बताना चाहूँगा कि सर्कल्स में दो इंपॉर्टेंट थ्योरम ये होती हैं कि सर्कल में अगर आप देखेंगे तो सर्कल में अगर आप कोई कॉर्ड खींचते हैं, तो जो हमें हिंदी माध्यम से जो बच्चे जुड़े हैं, अगर मैं उनको कहूँ तो अगर कोई आप जीवा बनाते हैं, सर्कल की सरकमफ्रेंस पर कोई भी दो पॉइंट लेकर के अगर आप उन्हें जोड़ने का प्रयास करते हैं, तो ये सारी डेफिनेशंस अभी आपको डिटेल में बताई जाएंगी. जस्ट आई एम यूजिंग द डिजिटल प्लेटफॉर्म टू शो व्हाट एग्जैक्टली आपको बनाना है, तो इसीलिए मैं इसका सहायता ले रहा हूँ. तो आपको करना क्या है कि जब आप किसी एक दो पॉइंट को मिलाते हैं तो उसकी जीवा कहलाती है, उसकी कॉर्ड कहलाती है, और वो कॉर्ड जो होती है सर्कल को दो पार्ट में डिवाइड करती है. एक मेजर सेगमेंट होता है और एक माइनर सेगमेंट होता है. ठीक है, तो ये दोनों सेगमेंट्स में जब आप डिवाइड करते हैं तो इन्हीं दोनों सेगमेंट से कुछ थ्योरम्स बनती है. तो जो पहली थ्योरम होगी, किट हमारी दूसरे नंबर पे होगी, बट मैं पहली थ्योरम अगर बताऊं तो ये हमारा अगर सर्कल है, ये आप हमारा सर्कल आप स्क्रीन पर देख पा रहे हैं, ये इसका सर्कल, ये हमारा सर्कल है. तो सर्कल अगर मैं कहूं इसको, और इसको पे मैंने कहा कि इसकी ये जो पूरी सरकमफ्रेंस है, इसकी ये जो पूरी सरकमफ्रेंस है, जो इसकी पूरी परिधि है, इस परिधि पर अगर आप कोई दो पॉइंट ले लें, मान लीजिए मैं यहाँ पर लेता हूँ एक पॉइंट और एक पॉइंट यहाँ पर लेता हूँ. ठीक है, ये दो पॉइंट मैंने ले लिया और लेट अस नेम इट, इसको मैंने ए डाल दिया और इसको मैंने बी डाल दिया. तो ये हमारी ए बी पॉइंट है. और इसके बाद मैं क्या, हमारी ये थ्योरम क्या कहती है कि एंगल्स in the same segment of a circle are equal in measure। ये थ्योरम जरूर आप सभी लोगों ने पढ़ी होगी, बट और बहुत सारे लोगों ने जो 9th 10th 10th में उन्होंने प्रूव भी करी होगी। इफ आई एम नॉट रॉन्ग प्लीज टेक्स्ट यस अगर आप लोगों ने ये थ्योरम पढ़ी है कि सर्कल्स की कि एक ही सेगमेंट में बने हुए सारे एंगल क्या होते हैं, उनकी माप जो होती है, जो मेजर होती है वो सेम होती है, इक्वल होती है। तो जल्दी जल्दी मुझे टेक्स्ट बॉक्स से टेक्स्ट करिए अगर आपने सुना है इस थ्योरम को, इस थ्योरम के बारे में सुना है अगर आपने, जल्दी जल्दी। थैंक यू चारू फॉर योर काइंड वर्ड्स। Sarita ji has texted not audible. I am continuously monitoring my channel as well, so I request you to please have some patience and yes Charu, yes sir, okay thank you for your prompt reply। तो ये जो थ्योरम है जिसके बारे में हम बात करेंगे कि इस एक ही सेगमेंट में बने सारे सर्कल की मेजर जो होती है इक्वल होती है। तो इसको डिजिटली हम लोग क्या करेंगे कि आप एक सर्कल ले लेंगे फॉर्म शीट पे, अगर आप सभी के पास कार्डबोर्ड है तो आप उसको बना भी सकते हैं राइट नाउ विद अस, ओके, और बनाएंगे, मैं ये एक्सपेक्ट करूंगा। तो आपने इसमें कोई 3 पॉइंट एक ही सेगमेंट में, अब ऊपर वाला जो है ये दो, अगर मैं कलर से बताऊं तो ये हमारे पास 2 सेगमेंट, एक ये रेड कलर का सेगमेंट हो गया और एक अगर मैं देखूं तो ये ऑरेंज कलर का सेगमेंट हो गया, ठीक है। ये 2 सेगमेंट हो गए हमारे सर्कल के। अब इस पर ये कह रही है थ्योरम कि एक ही सेगमेंट में चाहे जितने भी एंगल बने होंगे सारे एंगल की मेजर जो होगी, जो माप होगी वो समान होगी। तो आप इसको कैसे देखेंगे, तो आप ये करेंगे, पहले मैं एंगल बना लूं, ये लाइन है, एक एंगल मैंने यहां पर ये बना दिया, लेट मी टेक इट, लेट मी यूज द ब्लैक कलर अगेन, इसको आपने ये बना दिया। तो ये जो ए बी कॉर्ड है, ये जो ए बी कॉर्ड है, ये जो ए बी आर्क है, ये एक एंगल सबटेंड करी यहाँ पर। तो इस एंगल को मैं नाम सॉरी यहाँ पर इस चीज को मैं नाम दे देता हूँ, वेयर इज द टेक्स्ट बॉक्स, यस, ये एक हमारा बन गया, ठीक है। फिर उसके बाद आप सपोज ले लीजिए एक बीच में ले लीजिए, ये मैंने यहाँ ले लिया और मैंने इसको ये जोड़ दिया। तो ये ए बी जो आर्क है, ये जो ए बी पोर्शन है, ये एंगल एक सबटेंड किया यहाँ पर, ये इस सेगमेंट में। तो इसको मान लीजिए आप ले लीजिए डी, और एक और एंगल आप बना दीजिए यहाँ पर, ये बना दिए, ये थर्ड एंगल। तो आप यहाँ पर देख पाएंगे कि यहाँ पर आपको ये जो ए बी कॉर्ड है या जो ए बी आर्क है, ये जो ए बी आर्क है या ए बी कॉर्ड है, 3 तरह के एंगल सबटेंड कर रही है, ए सी बी, ए डी ई और ए ई बी। तो जो थ्योरम कहती है वो थ्योरम ये कहती है कि ये तीनों एंगल, ये जो तीनों एंगल बन रहे हैं, अगर मैं इसको दूसरे कलर से डिनोट करने की कोशिश करूं तो ये जो तीनों एंगल बन रहे हैं, ये पहला एंगल, ये दूसरा एंगल, सॉरी it is not working properly। ओके, एक जो ये एंगल बन रहा है और साथ ही साथ यहाँ पर एक एंगल ये बन रहा है, ओके। तो ये जो तीनों एंगल यहाँ पर बन रहे हैं, ए डी ई, सॉरी फॉर काइंड ऑफ नॉट बैड ड्राइंग, बट जो मैं समझाना चाह रहा हूँ यहाँ पर कि यहाँ पे जो 3 एंगल बन रहे हैं, एंगल ए सी बी, एंगल ए डी ई और एंगल ए ई बी, ये तीनों मेजर में सेम होंगे, यानी ये तीनों एंगल जो होंगे वो हमेशा बराबर होंगे। तो आप इसको देख सकते हैं, कुछ इस तरीके से समझ सकते हैं, ये एंगल जो होगा, ये एंगल जो होगा, ये तीनों एंगल आपस में बराबर होंगे। तो ये एक थ्योरम है। तो आपको इसमें क्या करना है, कार्डबोर्ड ले लीजिए, एक सर्कल बना लीजिए और ए बी कॉर्ड उस पर ड्रॉ कर दीजिए और 3 पॉइंट कहीं पे भी सर्कमफ्रेंस में ले लीजिए, सी डी ई, और सबको लाइन से जोड़ दीजिए। तो यहाँ पर आपने कॉर्ड से जो सबटेंडेड एंगल सबटेंड हो रहा है, जो एंगल बन रहा है आर्क से, वो आप देख पाओगे। अब आप क्या करो, इन तीनों में कोई एक पर्टिकुलर आर्क ले लो आप अपने कंपास से और एक एंगल बना दो, एक तीनों में बराबर है, आप तीनों में एंगल बना दो आप, ठीक है। एक सिंपल कोई भी मेजर ले लो, आप एंगल बना दो, ठीक है। फिर आप उसको काट करके बाहर निकालो। आप क्या पाओगे देखोगे आप कि आप जब इस पीस को निकाल लो बाहर, इस पीस को कट करके बाहर, ये जो आप यहाँ, आपको यहाँ पर एक कोई सा भी एक एंगल बनाना है, ठीक है, आपको एक एंगल बना करके एक छोटे से पोर्शन को, पीस को, जिसको वो पीस निकलने के बाद बेसिकली सेक्टर कहलाएगा, इस पीस को अगर आप बाहर निकाल लो, इस पीस को अगर आप बाहर निकाल लो तो आप पाओगे कि ये तीनों पीसेस एक दूसरे से इंटर रिप्लेसेबल होंगे। यानी आप ई वाले पोर्शन को डी में रख सकते हो, डी को ई में रख सकते हो, सी मतलब सी डी ई म्यूचुअली आप इंटर रिप्लेस कर सकते हो। तो ये हमारी द वेरी फर्स्ट थ्योरम, ये हमारी पहली थ्योरम थी जिसको आप आसानी से बना सकते हो, ठीक है। तो इसको मैं थोड़ी देर के लिए यहाँ पे रख देता हूँ। और जो हमारी दूसरी थ्योरम है, जो हम दूसरा जो आज आपकी वर्कशॉप में जो एग्जैक्टली आप किट बनाएंगे वो कुछ इस तरह से है कि जो एक आर्क है, सॉरी एक आर्क, एक कॉर्ड है, यहाँ पे सपोज ए बी है कॉर्ड, और अगर मैं इसको नाम दे दूँ यहाँ पर ए एंड यहाँ पर बी, तो ये आप देखोगे, आप पाओगे कि सपोज यहाँ पर मैं एक सेंटर इसका ले लेता हूँ, मैं टेंटेटिवली ले रहा हूँ यहाँ पे सेंटर, ये मान लो मैंने यहाँ पे सेंटर ले लिया कहीं, ठीक है, ये इसका सेंटर है। अब आप इसी कॉर्ड से ए बी से, इसी आर्क से एक एंगल सेंटर पे बना दो, ये मैंने सेंटर पे एंगल बना दिया, ये मैंने सेंटर पर एंगल बना दिया, ठीक है। सपोज हम लोग सेंटर का नाम दे देते हैं, सेंटर का नाम देते हैं O, ठीक है। और एक आप कहीं पे सरकमफ्रेंस पे बना दो, तो सपोज मैं मान लेता हूं यहां बना लेता हूं, ये और ये, तो आपके यहां पर दो एंगल बन रहे हैं। पहला जो एंगल बन रहा है इसको पहले मैं नाम दे देता हूं C, और ये जो पहला एंगल बन रहा है ये एक एंगल बन गया, एक एंगल बन गया, और एक एंगल आपका ये बन गया, ठीक है। तो ये जो थ्योरम कहती है, ये थ्योरम ये कहती है कि ये जो सेंटर पर, यहाँ पर आप देखोगे कि ये जो ए बी कॉर्ड है, ये जो ये पोर्शन है, ये जो आपका ये वाला पोर्शन है, ये एंगल सबटेंड कर रहा है यहाँ पर, ये जो पोर्शन है एक सेंटर पर बना रहा है और एक सर्कमफ्रेंस पर बना रहा है। तो ये थ्योरम ये कहती है कि जो सेंटर पर बनने वाला एंगल होगा वो सर्कमफ्रेंस पर बनने वाले एंगल का डबल होगा। मैं फिर से रिपीट करूंगा, वो जो सेंटर पर बनने वाला एंगल होगा वो सर्कमफ्रेंस पर बनने वाले एंगल से डबल होगा। लेकिन ध्यान देने वाली बात है, सर्कमफ्रेंस में कहां पर, ये जो कॉर्ड या जो आर्क सबटेंड कर रही है इसको छोड़कर, सर्कमफ्रेंस में तो ये भी पोर्शन आ जाएगा आर्क का, तो इसको छोड़कर जो रिमेनिंग पार्ट में कोई भी पॉइंट आप लेकर के अगर आप सर्कमफ्रेंस पर, उस सर्कमफ्रेंस पर अगर आप अंदर एंगल बनाते हैं तो वो हमेशा सेंटर वाले एंगल का हाफ होगा सर्कमफ्रेंस वाला, या सर्कमफ्रेंस वाला सेंटर वाला सर्कमफ्रेंस वाले एंगल का डबल होगा, ठीक है। सर्कमफ्रेंस वाला हाफ होगा सेंटर का और सेंटर वाला डबल होगा सर्कमफ्रेंस का, ओके। तो ये हिसाब है इस थ्योरम का। तो यहाँ पर अगर आप इसको थर्माकोल से बनाएं, या आप हमारी किट आप लेंगे बाद में जब भी, या आप अभी कार्डबोर्ड से अगर बना के देखेंगे तो आपको पाएंगे कि जब आप यहाँ पर एक एंगल बना दिया, यहाँ पर एक एंगल बना दिया, तो आप अगर देखेंगे तो इसको आप डिवाइड करेंगे अगर 20 से, तो आप पाएंगे कि ये जो ऊपर वाला पोर्शन है, ये वाला जो पोर्शन है जहां पर आप मेरा कर्सर देख पा रहे हैं, इसके जैसे दो पीसेस इसमें इन दोनों में फिट हो जाएंगे, इसके जैसे दो पीसेस ये सेंटर में फिट हो जाएंगे, ठीक है, जो रिप्रेजेंट करेंगे कि सर्कमफ्रेंस वाला सेंटर का क्या है, आधा है, और इस जो सेंटर पर बढ़ रहा है, इस सेंटर वाले का हाफ पोर्शन इसमें पूरी तरीके से, हाफ पोर्शन इसमें पूरी तरीके से फिट हो जाएगा। तो इस तरीके से आप विदाउट प्रूविंग, विदाउट डूइंग एनी मैथमेटिकल कैलकुलेशन, फिजिकली विजुअल फॉर्म में इस मटेरियल से, इस किट से आप इस थ्योरम को आसानी से समझ सकते हैं। सो आई होप यू हैव एंजॉयड द डिजिटल प्रेजेंटेशन ऑफ दिस किट। नाउ आई विल रिक्वेस्ट माय कोलीग श्री एन.बी. साहू सर टू प्लीज कंटिन्यू द क्लास, और यहाँ पर आपको एक प्रेजेंटेशन के माध्यम से आपको कुछ बेसिक डिटेल्स बताई जाएगी रिगार्डिंग द सर्कल्स एंड इट्स प्रॉपर्टीज, और फिर उसके बाद हम मूव करेंगे तो फिजिकली किट को किस तरीके से बनाना है। Okay, I got a few of the questions. Sir, how we will, Tanishka Srivastava is, thank you Prithvi ji, thank you Sonia ji. One of our participant, Tanishka Srivastava from class 9th D is, sir, how we will prove the previous theorem? Previous theorem में आप बच्चे बनाओगे जब, तो आप जब सर्कमफ्रेंस पे 3 एंगल बनाओगे तो आप पाओगे कि तीनों एंगल को ड्रॉ करने के बाद आप तीनों एंगल के जो सेक्टर है, जो पीसेस है, उसको कट करके आप जब बाहर निकालोगे ना, तो आप तीनों को कट करके बाहर निकालो, लेकिन जब आप रिप्लेस करोगे तो कोई सा भी आपके किसी भी तीनों में एग्जैक्टली फिट हो जाएगा। तो इससे ये प्रूव हो जाएगा कि वो तीनों एंगल इक्वल है मेजर में। सो आई होप आपको समझ में आ गया होगा तनिष्का। Tanishka, if you got if you are now comfortable with this solution or some answer, I must say, please reply. ये चेतना घोष जी is asking, yes you can make the kit on paper as well, but I request you कि पेपर बहुत ही पतला हो जाएगा, तो at least if you are not able to use some high rigid material, you can use at least the cardboard sheet. Hardly it costs around 15 to 20 rupees, so you can prepare it on that as well. So Tanishka sir, oh, thank you Siddesh Bhagwat ji for your kind words, kind remarks. Okay, a few of our participants are participating from आंध्र प्रदेश एज वेल। सभी को बहुत बहुत धन्यवाद हमारे साथ इस कार्यक्रम में जुड़ने के लिए। आई होप आई हैव आंसर्ड ऑल योर क्यूरीज। थैंक यू फॉर योर वैल्यूएबल कमेंट्स। Got it, sir. Okay, sir. Like, sir, do we have to make this kit? Yes. Virag is asking, we have to ask this kit. Yes, Virag, you have to prepare this kit. Yes, you have to prepare this kit. Now, without taking much of your time, let me take a few of your questions. Charu is asking, sir, we had the same workshop last year too. Okay, Charu, if I'm not getting, because maybe we have done some of the changes as well in the workshop. Let me introduce Charu is one of our Innovation Hub members, so maybe he has done the workshop in previous online sessions, or I must say, but we have made a few of changes in this workshop and programs as well. Sir, we will prove them mathematically. No, Tanishka, we are here focusing on the hands-on workshop. So you will prove it physically, in a physical manner, with the help of kit. You will prove it, Tanishka. If anybody has problem with Hindi, so you can open the subtitles. Okay. नहीं, हमने कोशिश की है कि इंग्लिश और हिंदी दोनों में बात की जाए, क्योंकि हमारे साथ बहुत जगह जगह से पार्टिसिपेंट जुड़े हुए हैं। तो मैं रिक्वेस्ट करूंगा कि जो भी प्रॉब्लम हो आप हमारे साथ साझा करिए, हम कुछ कमेंट बॉक्स को कंटिन्यूसली मॉनिटर कर रहे हैं। तो थैंक यू वेरी मच। नाउ आई रिक्वेस्ट साहू सर टू प्लीज कंटिन्यू द सेशन सर।
नहीं, अच्छा। Children, are you able to hear me? Children, are you able to hear me? If you are able to hear me, then I can straight away go into the program.
Yes, sir. You can continue, sir. Yes, sir. You please present your screen. Rahul. Okay. Sahu sir presentations, yes. Okay, yes sir. Sahu sir, you may please continue.
Children, if you're able to hear me, please do say yes, or please do write in the chat box. Yes, if you're able to hear me, then I can continue in the program. Okay. Children, as you are briefed to you, the topic today is circle and its properties. First of all, I'll be showing you some basic properties of a circle through a PowerPoint presentation. And after that, I'll be showing you the kit that we'll be taking up today for fabrication. Then, if time permits, we'll be showing you our work table, and the work table will be giving you a step-by-step guidance on how to actually fabricate and construct the kit. So this is a three-part program. First part of the program is some basic ideas regarding the circle. I think that we have already received some basic ideas of the circle, but I will tell you more things about the circle through this PowerPoint presentation. This is the first part of the program. This will be followed by the second part of the program. In the second part, I'll be showcasing the kit that we'll be taking up today for construction purpose. I'll be showing my work table. On the work table, I'll be displaying my kit that will be taken up for fabrication. Then in the third and final part of the program, I'll be giving you a step-by-step guidance on my work table on how to construct this kit at your home. So this is a three-part of the program. The first part of the program is coming now. It's a PowerPoint presentation on circle and its properties. Okay. I hope you are able to see my slide. What we call a circle. The basic definition of a circle. When a set of all points in a plane that are equidistant from a fixed point are joined, then the geometrical figure obtained is called a circle. First of all, circle is a geometrical figure. It is a regular figure. It is symmetrical figure. Okay. If you don't have a circle, suppose we have a curve, or suppose we have a pebble. Okay, the cross section of a pebble won't look like a circle because the pebble isn't a symmetrical figure. Now, the circle is the set of all points, the collection of all points which are equidistant, which are located from a fixed distance from a fixed point. So if you look at the figure on the bottom side, you will find there are three figures. First of all, you refer to the left-hand side figure. So here are the set of different points, okay? And there is a fixed point at the center. So the various points in a set are chosen in such a manner the points are equidistant from the central point. Okay, if you consider this point and consider this distance, consider another point and this distance. So all the points are selected obeying a condition that the points are lying on the plane and the points are located at the same distance from the fixed point that we call the center. The circle, in that case, look at the second figure. If you join such points which are equidistant from a fixed point, third figure, we are joining all these points, then we'll get a circle. The circle is the set of all points in a plane. Circle must be a plane figure. Circle is not a solid figure. The circle we can draw on a plane. So several things is highlighted by this statement. First of all, circle is a plane figure. Second thing is that circle is a geometrical figure. Then what we call a circle, the basic definition is also given in this slide. The basic definition of circle is that circle is the set of all points located in a plane which are equidistant from a fixed point. And next thing is that if we join all such points in a plane which are equidistant from a fixed point, we'll get a geometrical figure, and that geometrical figure is called a circle. Right? This is the standard definition of a circle. Now, I like to show you some examples of circles in our daily life and in nature. Circles in nature. There are innumerable instances of circle that we come across in nature. Okay, nature is full of circular shapes and circular designs. But due to the paucity of time, I've given you some few examples of circles in nature, but you will find many such examples in nature from your own ideas. Orbits of planets are nearly circular, although they are not perfectly circular. Okay, the planets move around the sun in almost circular paths. Okay, but according to Kepler's laws of planetary motion, the planets do move around the sun in elliptical paths. But for most planets, the eccentricity of the ellipse is so small, it almost resembles like a circle. It can be a very good approximation to regard the orbits of most of the planets around the sun as circles. If you look at the figure, we have the central body uh, at the center. Then different planets are moving around the central body in circle paths. This is Saturn. Okay, this is Jupiter. So all are moving in almost circular paths. Okay. Now, the next thing, the pupil of our eye. What is pupil actually? Pupil is a small aperture, this small hole located in our eye that controls the amount of light that has entered into the eye. Okay, it just acts like a window. Suppose there is bright light outside. In that case, the pupil will become small. The pupil is connected uh, with the ciliary muscles. Okay, the muscles can either contract and make the pupil small, or the muscles can relax and make the pupil large. Okay, so if there is bright light outside, then the muscles will contract the pupil, make the size of the hole smaller, so that less amount of light enter into the eye and eye is not be damaged. So depending on the ambient light, the size of the pupil, the hole, can be either enlarge or either diminish. But if you look at the particular shape of the pupil, then it is circular shape. So pupil of our eye are also circles. They're small circles. The circles in nature, the shape of water waves. If you drop, if you have visited a lake or a pond or a talab, if you drop a piece of stone in water, in the water surface, the stone will be dropping and hitting the water surface. That will create a disturbance in the water surface. Then ripples will generate, ripples. And water waves will spread all around the point where the stone hits the water surface, and circular waves will form. Concentric circular waves will come one after the other like a trend. We'll get concentric circular water waves starting from the point of impact of the stone, and they're propagating away from the point of impact. The basic shape of the water waves is circles. So these are basically concentric circles. This is yet another example of the circles in nature. Circles in nature, shape of most flowers are circular. Okay, here I've shown you one flower only, but if you look at in a garden, you'll find many flowers with petals, lovely petals with impressive colors. But if you look at the shapes, most flowers are circular in shape. The size shape of the sun, moon, and planets. This is a photograph of the sun, a closure photograph of the sun. Here on the sun's surface, you can see the turbulences, the gaseous turbulences in the sun's surface. Then outside this is the disk of the sun that normally we see with our naked eye. Although it is not advisable to look at the sun with naked eye, we require a filter to see the sun with naked eye. But if we have some filters or optical aid to look at the sun safely, then we will find the shape of the sun is a perfect circle. And the particular disk of the sun that we normally see with our naked eyes is known as photosphere. This is a photosphere of the sun. Outside the photosphere, you can see sun's atmosphere. This is the sun's atmosphere known as the corona. But if you consider the shape, in the corona, we will find gaseous flares Those are known as solar prominences and solar flares. Bigger gaseous jet circle solar flares and smaller gaseous jet circle solar prominences. That is outside the surface of the sun, erupting. Is eruptive prominences in the outside gaseous atmosphere of the sun. But if you consider the very particular shape of the disk of the sun, that is the photosphere that you usually see in the sky, it's a circle. And I like to emphasize is that not only the sun is circular, but also the moon is also circular. Not only the moon is circular, but also most planets are spherical. The section of that sphere is also a circle. So most of the heavenly bodies, most of the celestial bodies that you see in the sky, although they look like just point sources of light, specks of light, but if we magnify them and you see their true shape, they will be perfect circles. Okay, this is yet another example of circles in nature. Now, annual rings of a tree. Okay, if you look at a tree trunk, if you cut away, look at a cut away tree, the lug, if you look at the cross section of the lug, you will find several concentric circles. These circles are called the annual rings of this tree. Okay, each year, one particular annual ring is developed. So by counting the number of annual rings, we can estimate roughly the age of a tree. So the annual rings of this tree are also circular in nature. So there are various examples of circles. Okay, I've given the annual rings of the tree example. I've given the shape of the sun, moon, and planets are also circular in nature. That's yet another example of the circles in nature. And shape of the flowers. Most flowers with their beautiful, lovely petals spreading all around looks like a circle. And the water waves, the ripples, they are also concentric circles. The pupil of our eye that dilates and contracts depending on the ambient light are also circular in shape. And most planets' orbits, planetary orbits, are circle. Although, according to Kepler's laws of planetary motion, the orbits of planets are elliptical in shape, with sun residing at one of the focus of the ellipse. But this ellipse is not very much prominent. Almost they resemble a circular shape. So these are some of the examples of circles in nature. I think that you can have your own ideas. You can extend your own imagination and find many, many things around you in nature which are circular in shape. At the end of my program, I'd like to hear from you in the form of inputs in the chat box. What other things else you find in nature that resembles the circular shape? I'd like to have your own ideas. Okay, please do give your inputs on the objects that resemble circular shapes in nature. Okay, apart from the examples that I gave in my own presentation. Okay, these are the examples of things, natural things that look like circles. Now, there are common terms related to circle. I've told you, circle is the set of all points in a plane which are equidistant from a fixed point. That fixed point is the most important point to construct a circle. Okay, that fixed point is called the center of the circle. The fixed point in the circle is called the center. It is the point equidistant from all points in the circle. Okay. If I ask you a simple question, what do we need? What do we first need to construct a circle? Okay. Whether you need the radius of the circle to construct a circle, first. Whether you need the diameter of the circle to construct the circle, whether you need the circumference of the circle to construct a circle. So what is the first and foremost necessity to construct a circle? If I ask you this question, what should be your answer? Okay. But if somebody asks me this question, what is the foremost requirement to construct a circle? Then I would answer it is the center. Because at the center only you have to fix the pin of our compass. No? Then stretching the pencil at a fixed distance from the center, you have to move all around the center, keeping the same distance about the center. In that case, we'll come back to the point from where you have started and we'll get a circle. So the first and foremost necessity to construct a circle is definitely the center. Okay. Now the radius. Radius is the fixed distance between the center and the set of all points on the circle. Right? A circle has a fixed radius. Because the points, various points in the circle are equidistant from the center. So the distance between the center and any point and various points of the circle basically remain the same. So radius is a fixed distance from the center. Okay. Diameter is nothing but 2 times the radius of the circle. Diameter is a line segment. Yes, indeed. Diameter is a line segment. Okay, a line segment means it has 2 endpoints. A line segment has a definite length. Diameter is a line segment having boundary points of the circle at endpoints. The line segment ends on the 2 points of the circle. Okay, and diameter must pass through the center. If the diameter won't pass through the center, then it will become a chord. I remind you, diameter is the largest chord of the circle. So diameter is a line segment having boundary points of the circle at the endpoints and must be passing through the center of the circle. Okay. And if you measure the diameter, you measure the radius, the diameter will be twice the radius of the circle. In other words, radius will be half of the diameter of the circle. Then what about the circumference? Circumference is a curved line that encloses a circle. The length of the perimeter of the circle. What is perimeter of a circle? Is the outside boundary. Suppose you have a circular field. Okay. If you look at the football field, I won't tell you about the cricket field. The cricket fields, most cricket fields are elliptical in shape. No? But if you look at a football field is just like a circle. Okay. It has a boundary. Okay. And if somebody runs along the boundary of the football field, outline of the football field, and come back to the point from where you started the race, then basically you can tell that it's moving along the perimeter of the circle, along the boundary of the circle. Okay, so the perimeter of the circle, the curved line, is not a straight line. Radius is a straight line, diameter is a straight line, center is a point. But perimeter of the circle is basically a curved line. It is otherwise called the circumference of the circle. So here in this particular screen, I have tried to give you some basic definition of some key elements of a circle: the center, the radius, the diameter, and the circumference. Okay, I think you must have read these things in your school, in your class. You must be introduced about these things in a geometry class. But I'm reminding you and refreshing your memory once again. If you plot a circle on a rectangular coordinate system has 2 axes. One is the x-axis, another is the y-axis. Okay, suppose you take a piece of graph paper, and a graph paper you draw a circle. How can you draw a circle? With the help of a compass. Okay, first of all, you fix the pin of the compass at a particular point and mark that point at the origin 0 and 0. Then extend the pencil to fixed distance. Here the pencil has been extended from the center point by distance 0.5 inches pencil, and keeping the pencil fixed at the particular distance, move the pencil around the center and come back to the point from where you have started. Then basically you're tracing a circle. Okay, now what should be the coordinates of the various points of the diameter of the circle? Here you have shown you 2 diameters. Okay, one horizontal diameter and a vertical diameter. They are intersecting each other at 90-degree angle. Okay, now first let us take about horizontal diameter. Okay, this end, its coordinate is 1 and 0. Its x value is 1 and y value 0. Right? What is the coordinate of the other end of this diameter? Okay, y value is still 0 and x value is -1 comma 0. This is the coordinates of this point situated at the tip of the diameter, end point of the diameter, -1 0. This is the another end point of the diameter. Its coordinate is 1 and 0. This is all about the horizontal diameter. If you consider the vertical diameter, this is the vertical diameter. Okay, vertical diameter means y-axis. We're talking about the y-axis. So any point located on the y-axis, its x coordinate should be 0. So the coordinate of this point located on the y-axis is 0 and 1, 0 comma 1. X value is 0 and y value is 1. And the other point located at the other end of this diameter, its y value is -1, x value is still 0, and the coordinate is 0, -1. So, and the center, coordinate of the center is 0, 0. Here, the radius of the circle is 0.5 units. It is everywhere 0.5 units. Okay. So, if you plot a piece of circle on a graph paper, And if you try to measure the coordinates of different endpoints of the diameter, then maybe you'll be ending up kind of values like this. Now, next point. Now we'll be talking about the various theorems related to a circle. Okay, you know, we have already, Swapnil has already briefed you regarding a few theorems of the circle, but I have some more theorems to offer. The first theorem is the arc theorem. Okay, here some 6 theorems have been elaborated. The first theorem is the arc theorem. The angle at the center of the circle is twice the angle at the circumference. Okay, if this is the angle at the center denoted by 2x, if this is the angle subtended by the same arc, and the remaining part of the circumference angle is x. Okay, it is 2xx. The central angle must be double than the angle subtended by this arc at any point other than the arc of the circle. There is 2x, this is x. Okay, I'll be elaborating you and telling you how we come to prove this particular result. Okay. Then the next theorem says angle in the same segment that are subtended from the same chord are equal. Suppose we construct a chord here. This is the chord, okay, and this is the arc. Chord is straight line, arc is a curved line. This is the chord. And this is the 3 angles have been shown, subtended by the chord at different points on the circle. Okay, 3 angles have been shown, x, x, x. Because this is the same chord and the same arc, and all the 3 angles must be same. So angles in the same segment that are subtended from the same chord are equal. Okay, this is yet another theory regarding this, yet another theorems regarding the circle. Now the next theorem is the cyclic quadrilateral. Cyclic quadrilateral means if you inscribe a quadrilateral inside a circle. Okay, this is a quadrilateral. A quadrilateral is a closed figure having bounded by 4 sides. So if this is the circle and this is an inscribed quadrilateral, then this quadrilateral is called a cyclic quadrilateral. If you consider the opposite angles, B and D at the opposite angles of the cyclic quadrilateral, if you sum up the opposite angles, B plus D will be 180 degree. If you sum the other pair of opposite angles, that is A plus C, should also be 180 degree. So for a cyclic quadrilateral, the sum of the opposite angles is 180 degree. This is the third theorem regarding a circle. Now let's come to the fourth theorem. The angle in a semicircle is always 90 degree. Okay, semicircle is half of the circle. This is the diameter of the circle. The diameter divides the circle into 2 semicircles. All right, the diameter of the circle, and this is a point situated on the circumference of the circle. So this point subtends, diameter subtends an angle 90 degree at any point situated on the circumference of the circle. So that we say the semicircle is always 90 degree measure. Angle of a semicircle is measuring 90 degree. All right. That is a corollary of the first theorem. The first theorem says the central angle is double the circumference angle. Okay. So if you consider the diameter, the central angle is 180 degree, right? This is the angle situated by the same diameter on the point, on a point located in the circumference of circle. So according to the first theorem, the central angle must be double than the circumference angle. Okay, central angle, because it's a diameter, is 180 degree. 180 degrees double than this angle. Okay, so what should be this angle? 90 degree. So the angle in the semicircle is always 90 degree. That is a corollary of the first theorem. Now the fifth theorem says, suppose you draw a triangle inside a circle, and also we draw a tangent at any point. This is the tangent is the angle. Then this is the angle subtended by the tangent at one side of the triangle, right? This is the angle. This is one of the angles of the triangle. This is the angle subtended by the tangent. These 2 angles are called alternate angles. And this particular theorem is called the alternate segment theorem. It states that the two angles must be same. The alternate segment theorem states that the angle between the tangent and triangle is equal. So this angle, this is the angle subtended by the tangent. This is the angle of the triangle. Okay, the alternate segment theorem says that for a circle, these two angles must be the same. Now come to the sixth and final theorem related to circle. In fact, there are many theorems. I have selected only few basic theorems. So these are two. There is an external point A. From the external point A, we have drawn two tangents to the circle. Okay, one tangent touches the circle at the point B. The other tangent touches the circle at the point C. This particular theorem says if you have an external point and from that point, if you draw two tangents to a particular circle, both the tangents should measure the same. That is, length of AB should be equal to length of AC. Both the tangents are equal in length. Not only that, if you draw a perpendicular from the center of the circle to any tangent, okay, then the angle subtended with the perpendicular to the tangent will be 90 degree. Okay, this is the sixth and final theorem related to a circle. In fact, there are many theorems. I have selected only these important theorems related to a circle. Now have a look at the screen. The next slide. Circumference to diameter ratio of a circle. This is very important. Okay. For a circle, the ratio of the circumference to the diameter is always a constant, no matter how large or small is the circle. Here we have shown you two circles. So on a small circle, there is a large circle. Okay. Now come to the large circle. This is the circumference denoted by the letter capital C. This is the diameter denoted by the letter capital D. Okay, if you measure diameter, how can you measure the diameter? Because diameter is a linear figure, you can measure it easily with a scale or with a ruler. How can you measure the circumference of a circle? It's not easy because circumference is not a straight line. It is a curved line. How can you measure? Can you measure the circumference of a circle with the help of a scale? No, because scale can measure a linear figure. Right? So how can you measure the circumference of a circle? For that, we require a piece of thread. Okay, take a piece of thread, say cotton thread, put the end of the thread here, and stretch the thread all around over the circumference of a circle. Bend the thread, make the loop, and follow the circle, and come back to the point where we have started. Okay, now if you stretch out the thread over a scale, then you can have a measure of the circumference of the circle. Okay, I hope that you have understood what I mean. How can you measure the circumference of a circle? Okay, suppose you measure the circumference of a circle. Suppose you measure the diameter of the circle. C and D, both things are measured. Take a ratio of circumference to diameter, C by D, for a large circle. Now move on to the small circle, take a ratio, measure the circumference, small c, measure diameter, small d, take a ratio of these two values, you get c by d. Okay, you will get that always, no matter the size of the circle, maybe it is smaller, larger, always the ratio of the circumference and diameter will be a constant. Okay, the ratio is denoted by a Greek letter called pi. So the ratio of the circumference to diameter of the circle is a constancy, no matter the size of the circle. Okay. And it is denoted by the Greek letter pi. Pi doesn't have any accurate value. Pi doesn't have an exact value. For our day-to-day calculation purpose, we assume an approximate value of pi, that is 22/7 or 3.142. But pi is a non-terminating number. The exact value of pi has not been ascertained so far. But for our day-to-day calculation, we use an approximate value of pi, that is 22/7. So my point is that it's a very important property regarding a circle, that the ratio of the circumference to diameter of the circle is always a constant, irrespective of the size of the circle, and that ratio is denoted by the Greek letter pi. This is yet another property of a circle. Now, out of so many properties of the circle, so many theorems cited related to a circle, we'll be taking up only one theorem today, and based upon the theorem, we'll be making our model, and I'll show you how to make that model. Okay, that theorem is the arc angle theorem. Already I have briefed you regarding the arc angle theorem. Sukni has already briefed you regarding this theorem. The angle subtended by an arc of a circle at its center is twice the angle subtended by the same arc at any point on the remaining part of the circle. Okay, suppose you have a circle. Okay, suppose we have this arc. Okay, arc is a part of the circle. So this is the arc. This is the center of the circle. So this arc subtends an angle 2a at the center of the circle. The same arc subtends an angle a at any point on the other part of the circle. Okay, on the circumference. So if the central angle is 2a, the circumference angle must be half of that. That's a. That is the arc angle theorem. Okay. If the central angle is 2b, consider the right side figure. The circumferential angle must be b, half of that. So the arc angle theorem basically states the angle subtended by an arc of a circle at its center is twice the angle subtended by it at any point on the remaining part of the circle. Okay. Now I've given you some basic definitions about some key elements of a circle: chord, secant, and tangent of a circle. So what is a chord? Okay. This is some definition of a chord. The chord of a circle is a straight line. Is straight, not only straight line, is a line segment. Line segment means it has two endpoints. It has a fixed length. The chord of a circle is a straight line segment which endpoints both lie on the circle. Look at the figure. This is a chord. It's a line segment. It has two endpoints. The two endpoints of the chord must lie on the circle so that it will be a chord. Okay, the chord of a circle is a line segment, and the two endpoints must lie on the perimeter of the circle. Okay, you can measure exactly the length of a chord. Now, what is secant? Secant is a line extending infinitely in both directions. It doesn't have any fixed length. But if you have a line, okay, coming from infinity and intersecting the circle at two particular points, then that line can be called a secant. So the straight line that intersects a circle in 2 points, each called a circle. So the secant denoted by the green color. This is a line of infinite length coming from infinity and going to infinity. But while going to infinity, it cuts the circle at two distinct points. So this line must be called a secant. A secant must intersect the circle at two different points, not at one point. If the secant will intersect the circle at one point, then this will be no longer called a secant, it will be called a tangent. So what about the tangent? A tangent to a circle is a straight line which touches the circle at one point only. Okay, look at the figure. This is the figure. This is the tangent denoted by the red line, red color. The tangent is a line of infinite length, but that touches the circle at one point only. Okay. Unlike a secant would intersect the circle at 2 points. But a tangent, when the 2 points merge together, the line will become a tangent. The tangent is a line of infinite length that that touches the circle at only one point, and that particular point of touching is called the point of tangency. So I've defined some three important concepts about the circle: the chord, the secant line, and the tangent line. Is the same figure, angle subtended by an arc. If you consider this pink color, an arc of the circle, okay, this is the remaining part of the circle indicated by black color. This is the center of the circle. The pink color arc subtends an angle 2 theta at the center. Okay. Then the pink color arc subtends an angle theta indicated with the blue color at say point P1 at the point on the circumference of the circle. Then another theta we're getting indicated by the green color. Okay. So there are two thetas subtended by the same arc, same pink color arc on the two different points on the circumference of the circle. One indicated by the blue color, other indicated by the green color, and the central angle is indicated with the red color 2 theta. If the central angle is 2 theta, then the circumferential angle should be half of that, theta, theta, theta. No matter wherever the point may be located, the central angle must be double than the circumferential angle, right? Now, some other terms regarding the circle has been defined on this slide. Diameter is the longest chord of a circle. Yes, that is very, very true. Chord is a line segment that which two endpoints lie on the circle. So here we have shown you CD is a chord, EF is another chord, but the largest chord is undoubtedly diameter, indicated by 2R. AB is the diameter, is also a chord because it has two endpoints. The two endpoints are lying on the two different points on the circumference of the circle. So diameter is the largest chord, the longest chord of a circle. And the diameter, for that, the longest chord must pass through the center of the circle. If the longest chord will pass through, if the longest chord will not pass through the center of the circle, then it will not be the longest. It will no longer the longest one. For a chord to be the longest one for a circle, it must pass through the center of the circle. In that case, we'll call that longest chord as the diameter of the circle. Half of the diameter is radius, right? Now, having defined all these terms like diameter, secant, tangent, chord, now we'll define arc of a circle. Okay, because in our theorem, we'll encounter the arc only. Okay, an arc of a circle is any portion of the circumference of a circle. Okay, arc of a circle is a part of the circumference of the circle, right? Here we have shown you the full circle. Consider the figure. If we consider a small part of the circumference indicated by the black line, arc is a curved line indicated by the letter S. Okay, so the part of the circle is called the arc. If you consider this arc, the arc subtends an angle theta at the center, and the radius is still r. So my point is that arc of a circle is nothing but part of the circumference of the circle. Okay. Now there are some more information regarding the arc of a circle. The arc length is, suppose you have an arc whose length is s. R is a curved line. Suppose the radius of the circle is r. Then what is the angle subtended by the arc at the center of the circle? Okay, theta. How can you get the value of theta? There is a particular formula to express theta in terms of the arc length and the radius length. Okay, so this is the formula. This is the relationship connecting arc length, radius, and the angle subtended by the arc at the center. S is equal to r theta. Okay, what is theta? Theta is the center angle subtended at the center by the arc. But theta must be expressed in terms of radians. It's not be expressed in degrees. Okay, in this particular formula, theta should be expressed in terms of radians, not in degrees, mind you. What is a radian? The next question obviously comes to mind. What is a radian? Radian is also an angular measure, like degrees. Radian is also an angular measure. Okay, suppose you have a circle here, and radius of the circle is r. If we select a particular arc whose length is also r, okay, in that case, S is equal to r. Okay, look at the formula. If S is equal to r, that means the arc length and the length of the radius are the same, exactly the same. In that case, theta will be 1. S is equal to 1, r is equal to 1. This implies theta will be 1. So, if we have an arc whose length is exactly equal to the radius of the circle, then that particular arc will subtend an angle of 1 radian at the center of the circle, right? So what is radian? Radian is a unit of plane angular measurement, like degree, that is equal to the angle of the center of a circle subtended by an arc whose length is equal to the radius, right? If we measure the value of a radian, 1 radian will be approximately equal to 57.3 degrees. Like, all right. Now there are some more definitions, more terms regarding the arc of a circle. having defined the arc of a circle as the part of the circumference, then you can define two more terms related to the arc of a circle. One is the major arc, the other is a minor arc. What are these two arcs? 2 points lying in a circle actually define two arcs. Suppose you have 2 points, A and B. So A and B lying on the circle, they define two arcs. One is the shorter arc, AB, indicated by the red color, and another is the longer arc, indicated by the blue color. The shortest arc is called the minor arc, and the longest arc is called the major arc. So, if you have 2 points lying on the circumference of a circle, it can define two arcs. One, the shorter arc called the minor arc, or there is longer arc called the major arc. Right? Now, having defined the arc of a circle, we can go to define the sector of a circle. What is a sector? A sector is formed by joining the end points of an arc with the center, right? Suppose you have an arc. This is the arc. This is the center. This is the arc. These are the two end points of the arc. If we join the two end points, if we join the end points of the arc to the center separately, okay, then we'll get a figure like this, a conical figure like this, indicated by the shaded green lines. This is called a sector. Okay, a sector has an area. It is a plane figure, a closed and plane figure. So it must be having an area. So if we form a sector, then there will be two sectors in a circle. One is a minor sector, other is a major sector. The sector having the smallest area is the minor sector. The sector having the largest area is a major sector. But by default, we only consider the minor sector. Unless otherwise given, okay, we don't consider the major sector. We consider the smaller sector, that is the minor sector. If it is mentioned in particular that you consider the major sector, then we can consider it. But unless otherwise stated, we'll always consider our sector as a minor sector. So this is the sector. Now, how can we arrive at the proof of the arc theorem? That is, the central angle is half of the angle. Look, half of the circumferential angle. How we can get that theorem, prove that theorem? Okay. This is a direct proof of that theorem. This is not very difficult to understand. This is a circle. APBA is a circle. O is the center of the circle. Okay, our arc is AB. AB is the arc, the minor arc. The major arc is APB, the arc. O is the center of the circle. Suppose you can, then what is the central angle? Central angle is angle subtended by the arc at the center. What is that? AOB. AOB is the central angle. Okay. Consider any point located on the circumference of the circle other than the arc. P is that point. Then the angle subtended by the same arc at point P is this arc, is this angle, right? So the theorem says that the central angle must be twice this circumferential angle. Okay, so how you can prove that? There are two triangles. One is the triangle AP, one is the triangle APO. APO is a triangle. Okay, for this particular triangle, this is the AOQ. AOQ, this is the exterior angle. The exterior angle must be equal to the sum of the two interior opposite angles, right? This is a theorem related to the triangle. So the angle AOQ, the exterior angle, must be equal to the sum of these two angles, interior angles. AOQ is equal to PAO plus APO. PAO plus APO. This angle and this angle, the sum is this angle, exterior angle. This is true for the triangle APO. Now, if you consider another triangle BPO, this is a triangle BPO, but BPO, this is the exterior angle. BOQ is the exterior angle. These are the two interior angles. So exterior angle, this angle must be sum of these two interior angles. That is VOQ is PBO, angle PBO plus angle BPO. So two equations are getting, okay, connecting the exterior angle to the two interior opposite angles. Okay, if you add up these two equations, in the third line, we'll get this result: angle AOQ, AOQ is this one, plus angle BOQ is this one. So the two exterior angles have been added off. That will form the central angle AOB. Okay, now we are coming to the central angle. When these two angles added off, left hand side is the central angle, right hand side is what? Angle PAO plus angle APO plus angle PBO plus angle BPO. Okay, PAO, first consider PAO, PAO. Then consider APO, APO. This angle and this angle are also the same because this triangle is an isosceles triangle, because the two sides, these two sides are nothing but the radius of the circle. Radius is always the same. Okay, these two angles are equal. PO, PAO is equal to APO. Okay. Similarly, PBO, PBO is equal to BPO. These two angles are also the same. Okay. So if you move ahead further, then we'll end up AOB, AOB, central angle will be twice this angle, circumferential angle. So by this geometrical construction, we can easily prove the arc angle theorem. I have a simple problem for you. Based on this arc angle theorem, if the central angle is 80 degree, what should be the angle subtended by the point C located on the circumference of this circle? Okay, at the end of my program, then please write in your answer, your response in the chat box. What should be the value of X, and show it to me at the end of the program. And the kit that we'll be taking up today for fabrication, the kit today will be this kit. Okay, I'll be showing you the actual kit while I will display my work table. A circle has been shown in shaded red color. Okay, then this is the arc. This is the center of the circle. Okay, then there is a piece, cutaway piece here, conical cutaway piece here. This piece, I've cut it out, and this piece also have cut it out. Okay, this is the central piece. We have divided the central piece in two halves. Okay, this is the piece located at the circumference of the circle. This is the central piece. Okay, now you take one of the central piece, half of the central piece. Suppose you will take this piece, it can easily fit it out here. Okay, that circumferential piece also can easily fit out here. You can exchange any of the three pieces. Okay, they will exactly fill up the space. Okay, so that proves that half of the central angle, one piece at the central angle means half of the central angle. Half of the central angle will be equal to the angle formed by the arc at any point located on the circumference of the circle. Okay, this is all about the kit. I'll show you the kit actually. Now, what are the materials required to construct the kit? We require sunboard based board. Sunboard is a soft board that is suitable for cutting. You can easily cut it out with a piece of knife. Sunboard is so soft that you can easily cut it out and make it different shapes with sunboard. It is easily available in hardware shops. We require some drawing pins, 4 numbers. We require foam sheet. We require nylon shoe. If you don't have nylon shoe, then it doesn't matter. Without nylon shoe also, we will get our design effect. Then we require some Fevikwik glue. Then we will require a paper cutter knife. So all these things are the materials required to construct this kit. Okay. Now, thank you all for having a patient hearing of my presentation today. This is all about the theory regarding the property of a circle. In my theory, I've tried to highlight not all the properties, but the very property of the arc theorem. Arc theorem of the circle, that is, the arc subtends an angle at the center, which is twice the angle subtended by the same arc at any point on the remaining part of the circle. Okay. So to illustrate that, we have a kit. Okay. So now we'll switch over to our work table, children. Okay. Within a few minutes, I'll be showing you my work table. On the work table, you'll be getting the kit ready. I hope that you must have gone through my presentation regarding some basic properties of a circle. I hope that you must be learning about these things before, but I've tried to make it a summarized form, and I've tried to give you again a recapitulation of what you have learned so far in your school curriculum, mathematics curriculum. Okay. This is the kit actually. Okay. This is the kit. Now the red color signifies the circle, right? Now you have shown the central angle. This is the central. If this is the center, and this is the arc. This is the arc. This is the arc. This is the central angle, right? Okay. Then we have cut it out. The central angle. We have cut it out. Look at this cut piece. Not only have cut it out, we have also divided the central angle into two different halves, two equal halves. You see, these are two equal halves. If you join them together, they produce the whole central angle, right? So this is the central angle. This will easily fit at the space of the central angle. Okay. To lift it easily, we have fixed the two pins over the pieces that make up the central angle. Look at the pins. फिर से करना पड़ेगा. Children, we hope that you must be seeing our work table. So you see the central angle, and these are the two pieces that make up the central angle together. We have divided the central angle piece into two equal halves. These are two equal halves. If you connect them, join them together, this will form the whole central angle. This angle can be easily fit at the central angular space. Okay. To lift this pieces, we have connected the pieces with a peg, with a drawing pin. Okay. This is the piece that measures the central angle. Okay. I'm putting it here. This is a measure of the central angle. Okay. Now we have another angle defined by the point P. Point P is located on the circumference of circle. Okay. This is the angle, and this is the angular piece. Again, to lift this angular piece easily, we have connected one peg at the upper surface of this piece. Okay. So this is the circumferential angle. Okay. Now the theorem says the central angle must be twice than the circumferential angle. Okay. This is the central angle. We have divided the central angle into two equal halves. Okay. Both the halves should measure the same. Okay. If you put one piece over the other piece, they should measure the same. Okay. That you can do that easily. Or there's yet another way to prove that the central angle is double than the circumferential angle. Okay. This is the central angle. Okay. This is the circumferential angle. You can lift either of the central angle pieces and put it here at the circumferential angle. You will find it exactly fills up the space. That means half of the central angle is equal to the angle created at the circumference. If half of the central angle is equal to the angle at the circumference, then the whole central angle must be twice the circumferential angle. Okay. So we have three pieces here. Okay. You can interchange the position of the three pieces. Any of the two pieces can be fitted at the central angle, and any of the remaining piece can easily fit at the circumferential angle. Okay. So that proves our theorem that the central angle is half. Central angle is twice actually the circumferential angle. Okay. So this is uh, the kit, second part of the kit. I showed it to you. Now, Rahul, now I would request Rahul to carry this program forward and to show you actually how to construct this kit. Okay. Uh, uh, for that, you require for that you require some raw materials. Already I have told you. Uh, you'll require a scale, you'll require a paper cutter knife, you'll require 3 drawing pins, and you'll require some foam sheet boards. Okay, 2 foam sheet boards are required, one to serve as a base, the other to serve to make the circles. Okay, so first of all, we'll take the foam sheet and draw circle here. Look at the figure how you can draw a circle. On this circle, the central angle has been shown. Also, the circumferential angle has been shown. Okay. Now we have to take a paper cutter knife. Okay, and cut the angles, cut the lines. Okay. Now, Rahul, cutting कीजिए ना. So this is the paper cutter knife. This is a scale. बच जाइए. इधर बच जाइए. Now please try to cut with the help of a scale and paper cutter knife. All right. First of all, cut away the central angle. For that, you will take a scale. First you cut this angle, central angle. This angle, cut along these lines. Children, while using a knife, you should be very, very careful. You should ensure that the knife doesn't cut your own finger. A scale is required to cut away the piece. कट कीजिए ना, कट कीजिए. क्या क्या होता है? Not only you are required to move knife once, you have to move it several times. Each time the knife moves, you'll cut a little. So by moving the knife several times, you'll be able to cut out the entire piece. But that you should have enough patience to move the knife several times, not just once. Yes. Because it is soft board, you can easily cut it with a knife. Okay. First cut this piece, this one. Now we'll cut away along the arc. Arc is a curved line. There you have to be careful so that it exacts the cut along the arc. You have to put the blade of the knife over the arc and move it slowly and steadily so that the entire arc has been cut. Yes, you have to move the blade again one more time. It should not be hurry at all. Okay, let it take its own time. Doesn't matter, but it should have a perfect cut. Otherwise, the pieces won't match. Then third time we are moving a knife, whatever material left uncut. Now that will be cut by moving the knife in the third stroke, okay, and you are able to perfectly cut it. Now we'll give a little push using your fingers so that the conical piece will come out. This is the conical piece, this is the central angle, okay. Now we have drawn a line. This is the line that divides the central angle into two equal halves, okay. We'll move our blade along this line and divide the central angle into two equal halves. Cut karo. Okay, so the central angle has been divided now into two equal halves. On one half, I'm writing, say A. This is A. On other half, I'm writing B. Okay, this is the central angle. All right. Now we'll cut away the circumferential angle. This angle is the circumferential angle. We'll cut it out. After cutting along the straight lines, now we'll go on to cutting the curved line. Move the blade gently over the curved line. After several strokes of the blade, we'll be able to achieve a full cut. This will take some time. Okay. Just don't be in a hurry. If it takes some time to cut a curved line, then it is worth paying little time to cut that line. All right. Now giving a little push with our finger, we'll be able to extract the circumferential angle. This is the circumferential angle. Okay. I'm denoting it by the letter C. This is the circumferential angle. Okay. So three angles have been cut. Now to lift these three pieces, we'll attach the pegs. These are the pegs. Attach the pegs. Just inside, pierce the pin of the peg into the pieces. Okay. The pegs are required to easily lift the pieces and place it at their desired spaces. Now we have now 5 pieces. 1, 2, 3, 4, and 5. These 3 are the angles. Okay. This is the arc of the circle. This is the arc. This is our baseboard. Okay. Now taking some Fevikwik glue. Okay. To fix this part over the baseboard like this. Okay. But that doesn't matter. You can put it in any fashion. Okay, you can put it in any fashion. Like this, you put it and join it Fevikwik glue. Fevikwik glue is required. Fevikwik is a hard glue. All right, children. Now we have 2 angular cavities. This is the angular cavity that defines the central angle. This is the angular cavity that defines the circumferential angle. We have 3 pieces here. 1, 2, 3, A, B, and C. Okay. If you put these 2 pieces like this, okay, then this will fill up the space of the central angle. Okay, you can take away any piece and put it at the circumferential space. This will exactly fill up the space at the circumference. Okay, so by this simple activity, you can prove the very important geometrical theorem related to the property of a circle, that for an arc, the angle subtended by the arc at the center is double the angle subtended by the same arc at any point located on the remaining part of the circle. So this is our kit, children. Okay, you can easily make this kit at your home. Suppose you have all these materials at your home sheet boards are required, pegs are required, then scale, cutter, all these tools are also required to fabricate this kit at your home. So please do make this kit at your home and do enjoy playing with these kits and eventually verifying a very important theorem related to the property of a circle. So now we have concluded all our presentations here, discussions here. Now, if you have any inquiries regarding anything that left untouched, regarding any doubts that has not been cleared so far during my presentation, you can display your queries in the chat box and wait for my answer. Okay. If you have any थोड़ी कुछ पता है लगा left in minds, then if you need the doubts to be cleared from our end, please display your doubts in the chat box by typing in your queries. I will just answer orally, mouth to mouth answer. क्या करेंगे, कुछ करेंगे ना क्या? No. Children, I like to know from you whether you have understood our lessons today. If you have understood our lessons, no doubt left in the mind, please do write yes, understood. If you have any doubt, please do write doubt. All right. Oh yeah. क्या पूछ रहे हैं?
Can we tangent a special case of secant?
Yes, you can read. अच्छा one
Is the radius is the length line segment?
मुझे तो दीजिए मुझे अच्छा in the meantime I have received some questions. Some curious participants have written some questions and in the chat box, and let me go through your questions and my answer will follow in a circle from now. So what are your questions? The Prithviraj Gupta. Prithviraj Gupta has put up a question, very interesting question. Sir, can we call a tangent a special case of secant? Yes, you can call a tangent a special case of the second. Yes. इधर में कुछ आपका previous मेरा आवाज आएगा. Okay. So Prithviraj, your query is very true. A tangent is actually a special case of the second. A second cuts the circle at two different points. But if the two different points will merge together, then the second will touch the circle at a particular single point, and in that case, that special second can be called a tangent. So it's very true. A tangent can be regarded as a special case of a second. Then another question from Pratham Singh. Sir, this radius is a length and line segment both. Radius of a circle is having a fixed length. Okay, a line segment is each part of a line segment is also having two endpoints and fixed length. Since radius of a circle is having two endpoints and having a fixed length, so radius can be regarded as a line segment. Yes, it can be regarded as a line segment. Another question from SSL Basanta. Comments from SSL Basanta. Today's class was amazing, sir. Learned many new things. So thank you, Basant. Okay. I am also equally happy that my lessons have been successfully delivered. And Virag Joshi says, sir, can we leave? Yes. If you are eager to leave, we can leave. Virag Joshi. Virag. Prithviraj Gupta. But how, sir? Aditya Rai says, sir, we get kit or not? Regarding the kits, okay, regarding the distribution of kits, okay, we will subsequently, in the course of time, we will be giving you the information whether and how you will be able to access and get our kit. But till now, please wait for a message to come regarding the distribution of the kit. But as of now, this presentation and the lessons has been successfully delivered, as it appears from your comments and chat boxes. So we say thanks to all of you, and we also feel equally happy in presenting the program for you. Thank you.